Piecewise functions, we've got three pieces here. We've got a line, quadratic, and then a constant. So we're just going to break this guy up into three different pieces here. And we know that the break will happen at -3, and then will happen at +1. So we're going to have a little sliver in the middle here that will be, just a second. Okay, good. We'll have a little sliver that'll be the middle guy here. So it just doesn't matter. Let's go ahead and just do the, sorry. Oh my gosh, dogs. Let's do the quadratic first. Why not? It's in the middle, and we know it's between -3 and 1. So it looks like he's just a parent function that has dropped down 1. So I will go in blue here, and he's going to go over this way. He's going to drop down 1, and then he's going to move over 1. But I'm not allowed to be there at those locations, so I will put a circle there, an open circle. A little hard to see though. But then he's going to go all the way to -3, so that would be here, and then over 2, 4. And then over 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that'll be open. So this guy will go like there. Okay. And check. He's done. Now we've got this guy who is +3. He's going to be over here on this side. He's going to be +3. 1, 2, 3. But he's going to go down the slope of half. So he's going to go down 1 over 2. Down 1 over 2, down 1 over 2, down 1 over 2, okay? Of course, I just gave him a positive slope. Let's try that again. 1, 2, 3, okay? Down 1 over 2 is this way, so let's go backwards. There we go, right here. Okay. Yeah, let's try that again. 1, 2, 3, over 2, down 1 over 2, down, yeah, down, ooh, oh my gosh, I cannot believe why this is so hard. Here, 1, 2, 3, okay, over 2, up 1, over 2, up 1, I'm saying it wrong, over 2, up 1, okay, so this guy going to go right about here, and he's going to take off, and we're going to give him a solid dot. Okay. Ooh, boy. Now this guy's just a flat line, a piece of cake. So he's going to go to 3, and he will just start here at 1, but notice it's an open circle. So right there. Now that's actually, the open circle is important for when we do the domain, because we pretty much got all real numbers covered except right there at 1. So what you can do is just put x does not equal 1. Okay, that's perfectly fine. We're all set. Now the range for this guy, actually, we do have this arrow going off to infinity, and everything is covered up until here. So it looks like our range, okay, is all y, but that's greater than or equal to -1. Okay. Now remember, there's a couple different ways to do that. We do have jump discontinuity twice. Jump, 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 jump. Jump discontinuity at x equals -3 and 1. All right. And yeah, that's good. So this right here looks like, I'm just telling you, is it positive or negative, even or odd? We've got this guy and this guy. That is an even positive. Okay, this guy is it's got the 2 arrows there, so that is actually a negative odd. Okay, that's all that needs to be written for that. All right, these guys right here, I would, unless it's in factored form, I would not expect you to graph it. So basically, you would use your graphing calculator for this. Okay, so graphing calculator. We do know a couple things. We know that it's a negative even right here, so we know that like in the long run it'll go like that, and that's totally fine. So we could say like the domain would be all real numbers like relatively quickly. And then we also know that as x goes to negative infinity, as x goes to positive infinity, f of x and f of x are both going to negative infinity. So that's another thing we could write relatively quickly. Okay, so with everything else though, everything else we're going to have to kind of going to have to tease out with our, because we don't know how high we go either, so that we know we go from negative infinity, but we don't know like till when. Okay, so that's going to require us to use the graphing calculator. So I'm going to have to do that. There's no doubt about it. Where are we at? 5-minute mark here. Okay, and let's see if I can make this a little. There we go. And so y equals, turn off the plots. We've got negative x to the fourth minus x to the third plus 4x squared and then minus 5. Okay, so let's do a zoom standard. We'll just take a look here. Okay, so I'm not going to graph this on paper. What I'm going to do is I'm going to look and see where those values are. And I can figure out where the x-intercept. Well, first of all, the x-intercept right there, I'm sorry, y-intercept is right there at negative 1, 2, 3, 4, 5. Okay, so we can say that we've got the x-intercept, y-intercept right there at negative 5. Okay. Now the x-intercept looks like 2 locations there. Okay. And then we got mins, we got increasing intervals and all that. So if we want to do the increasing and decreasing intervals, we want to know where the maxes and mins are. So we can go to calculate, and the 0 is going to tell us where it hits the x-axis. So I'm going to go to the left of it, I'll go to the right of it, and I know that my 0 is squeezed in between there. So when I hit guess again, looks like I have a 0 at x equals negative 2.32. Okay. Now the other one is go again, go 0, and now we're going to move over our left bound over here, and then we're going to go to the right here. So it's in between there. Guess is right there, and that one is negative 1.14. Okay, so that's good. Now, for the mins and maxes, let's go back to calculate. So let's go ahead and do the graph has a max right around here. So let's go to the left bound there. Okay, and then right there. So there's the max. Looks like the maximum is, I did the max first. So at x equals negative 1.83. Okay, and it also means that the highest I go is 3.31. So 3.31 is actually going to be my range. That's as high as it goes. Okay. So instead of doing this, what I can do is take care of all that information like this. Okay. So there's a max, and then I'm going to do that minimum there. Now my absolute minimum, I don't have one because he goes all the way to negative infinity, but I do know a relative minimum is right there. The guess is right there. Okay, and it looks like it basically happens at that x-intercept. So it's that minimum is 0. So the minimum, relative minimum, is at 0, negative 5. Again. Okay, and then I'm going to find that relative max again over to the left of this guy right there, because he's important because he's going to help me know when things are increasing. So then we've got 1.09, and then it happens at negative 2.95. Now what this is going to do is it's going to allow me to get the increasing and decreasing intervals because I wrote down the y coordinates for these guys. Okay, so increasing interval. Well, looks like I'm increasing at 2 locations, 1 and 2. So that would be from negative infinity all the way up to the negative 1.83. Then I start again right there at 0, and then I go to 1.09. So I start at 0. So right here, I increase up to that point, the max, which is right there. Then I decrease, okay? Then I increase from 0 up until that point, and that point is right there. Now I'm looking at whenever we say intervals, we're talking about the domain, okay? We're not talking about the y coordinates, we're talking about the domain. Now, the decrease happens when from negative 183 to 0, okay? Then it decreases again when we get to 1.09, but then it's going to decrease all the way to infinity, okay? Now, I know that this, you might be thinking, like, this is decreasing, that's decreasing, but remember, we read this, okay? We read this like we're moving left or right. So this is increasing, decrease, increase, decrease, okay? All right, that's it. That's the nutshell for this guy. And so we're going to do the same thing for him. Let's just go ahead and separate this in another video.